And okay. All right, guys. Sorry for the delay. The computer was acting funky, um, probably because I hadn't shut it down and restarted it for a while. So, okay. So fun stuff. So a couple of you guys have emailed me, messaged me about the assignment. Let me. I want to go ahead and talk about that a little bit because a couple of you have emailed me asking about using multi-dimensional arrays. And actually, yes, that's absolutely acceptable. As I've said to many of you throughout the course of this semester, if you want to use any technology that we have not covered or any items that we have not covered yet in this class because you've either researched it yourself or because maybe you're taking this class for the second time and you remember it from a previous semester, that's perfectly acceptable. But you will be expected to understand why maybe those higher level technologies are necessary. The main thing I want to remind everyone is when I give you guys an assignment, by the time that the assignment, we'll give you about 2 weeks usually to do it. By the time a week has passed between the time that it's been given and then a week later, you have all the tools necessary to make the assignment at that point. It may not be the cleanest solution. It may not be something that you would want to give when you're working as a full-time programmer one day, but you have all the tools necessary to make the assignment happen. And that's the important part, is that I need you to be able to do those things. Okay? All right. So let me go ahead and I guess let me share the screen for the assignment stuff because there's a couple of questions that I wanted to put out there. If I can remember some of the things that were being asked. All right. So reminder, this is going to be due basically the last Monday of this year. So 2020 is coming to an end finally, right? A couple of things. One, if you want to create other methods that aren't listed here and you want to define them however you want, that's fine. Like, I have no problem with that. We will test what methods you have here. Okay, we will test the methods that we have said we need to be able to see. Okay, so anything that you do that is different from this, it may end up being a problem for our test cases. One I want to put out there as very important. Throughout your program, create only one scanner object. Okay, if you create multiple scanner objects, like inside of display menu, you create a scanner object to get input from the user, but then inside of course grade, you create a different scanner object to be able to get input from the user for what they want to do. That will cause problems with our test cases, and some of our test cases will fail and you will get a lower grade. Okay, this is the reason why I said in the definition of the program here, pass the scanner object to the display menu. That way you don't have to create a second scanner object. Okay, so again, if you create two scanner objects, most likely you will cause problems for our test cases, which isn't going to cause any problems on our computers or isn't going to cause any problems like that. What it's going to do is going to give you a lower grade, and so just don't do it if you want to get the highest grade possible. Okay, let's see. What was something else that a couple of you again, for course grade, we are not getting this information, category, quantity, and weight from a scanner object from the user. We're not getting that from the console. We're passing that through a series of arrays. So there will be a string array that is the categories. It can be anything in there. It could be, as we've shown in the example down below here, it could be quiz, homework, midterm, final. It could be that. It could be something else. Don't assume. One, as I said last week, or whenever it was the last time we talked about this, do not assume that it will be 4 categories, okay? It could be 1 category. It could be 6 categories. I did say that there would be a maximum of 6, okay? So go ahead and you can say that it'll be a maximum of 6. As far as then the quantity and the weight, we're going to pass those as integer and into two integer arrays. Sorry, two integer arrays. Okay. Assume that for this assignment, whatever the number of categories are, we will keep the same number of quantities and the same number of weights. Okay. So what that means is that if I give you 6 categories, I will give you 6 quantities, I will give you 6 weights. I'm not going to mix them up and make you have to test for that in this assignment. A future assignment, there is time for one more assignment before the end of this year, and we will give one related to that. In a future assignment, that may not be the case. You may need to check to make sure the number of categories and the number of quantities and the number of weights will all be the same. Okay. One last thing, a reminder that next week you will have a quiz. Now we won't have a class, we won't have a lecture on Thursday because of the New Year's holiday, but I will go ahead and give the quiz on Wednesday. Okay, so there won't be anything on Thursday, the 31st, but on Wednesday the 30th at 12:30, you will have a quiz based on this assignment, just like you did last time. Okay, make sure I'm saying it here. I'm going to make the announcement on Teams today, and I put it here in the assignment description. Some of you missed the last quiz, okay, because you had the date wrong or the time wrong. I don't remember which. All right, and that can't happen again. Okay, there's no excuse for missing this quiz. Okay, so make sure you're there for it. All right. Okay, so as I said, the easiest way, I would say the best way, maybe not the best way, I shouldn't say that. One of the easier ways to be able to commit to make this assignment would be a multi-dimensional array. And let's talk a little bit about how multi-dimensional arrays work then today. All right. So what I'm going to do is let's see, share those slides. I apologize. One other thing I wanted to say was I realized that I had the slides in my Google Drive where I keep all my slides before uploading them to you guys to the team folder, and completely forgot until today to upload it to the team folder. So I apologize for that. So you didn't have access to them until today. Sorry about that. All right, but basically we did introduce multi-dimensional arrays last week. One of the things that I talked about last week was I talked about what if, like what I said was the advertisement, right? The reclam, the little preview for for this week was what if each of those arrays. What if each of the items in an array pointed to another array? And that's basically what a multi-dimensional array is. So imagine we had a situation where we wanted to keep like a table of things, like distance. Okay, so this distance is in miles between cities. So obviously across this diagonal, the distance between a city and itself is 0. That makes sense, right? But we wanted to keep a table of distances between two cities, between Boston and Chicago, between New York and Chicago, and so forth, right? Now, if we did this using an array, using a single one-dimensional array, we could have this here. We could have Chicago to all these different cities in a single array. All right, that'd be fun. But what if we wanted to add Boston? Okay, well now we need a new array. And New York, now we need a new array, and Atlanta, and Miami, and so forth, right? Well, what happens if we want to add a new city to our thing? Well, we have to create another array, and we also have to extend the size of all of these. Wow, that can get really, that's a headache, isn't it? All right. Well, Java, as many other languages do, provide us an ability to have what we call multi-dimensional arrays, where each item in an array is an array itself. And so you see we use the double bracket notation. We'll talk about that, right? So basically what we're saying is create an array of arrays. And each of those arrays is its own single one-dimensional array in there. Okay, so this is an example of a two-dimensional array. Two-dimensional because we have a row and a column. Okay, and as we'll see towards the end of this lecture, toward the end of this set of slides, we can have as many dimensions as we want. We're not limited to only two-dimensional arrays. All right, but in programming, generally we don't go beyond three, and that'll be explained. I'll explain a reason for that. All right, I won't go through this. Okay, but the same way that we declared a single one-dimensional array is the same way that we declare a two-dimensional array. We just add a second set of brackets. So we say, okay, whatever the reference variable is, whatever the variable name is, data type, bracket, bracket, and whatever its name is. And we can create, like in this situation, we can create a 10 by 10 array. Okay. Now, we'll talk about how we can create some of these dynamically and some other stuff, and I'll show you some examples of that, okay? But what we'll see is, and one other note, as you'll see later on in a set of slides, is not all the arrays inside of this have to be the same size. We can have what's called ragged arrays, where each array inside could be a different size, and then there's some reasons for why we might want to do that. Okay. All right. So here we can create and we can combine the declaration and creation in one statement, just like before, where we don't have to declare and then create. We can do it all together. And then also we have the alternative syntax of the brackets after. I generally don't use that, and the text here suggests that we generally don't use this syntax, this one here, basically because what we like to say is basically this is the name and this is what it is. Okay. Whereas if we do it this way, it's like, okay, is that the name? Well, no, but okay. So this is a little bit cleaner, but there is nothing syntactically, nothing as far as a compiler is concerned, there's nothing wrong with this. Okay. All right, it's just harder to read sometimes because somebody reading your code, for if you're working in a company one day, or if you're working on a project at school and your teacher or another student or a teaching assistant rather wants to look at it to grade it or to help you understand why something might not be working, we might be confused when we see this and think, well, this is a integer or double or whatever. Why are you using an integer or double? Oh, well, I didn't notice that bracket stuff. Whereas with this notation, we immediately know this is an array. Okay. All right. So here are some examples where we might say, okay, integer double two-dimensional array matrix is a 10 by 10 array. And then we can set a value just like before. But now, in order to set a value, we don't just need one index, we need two. So if we look at the first index as being kind of the row, and then the second index as being the column, now we get to a value. Remember, this let me, if I can just highlight just this part here. Okay, this part right here is saying go to the first item in matrix. What is the first item in matrix? Well, the first item in matrix is a 10 value array. Okay, so what I get when I access this is I get a 10 value array, a 10 slot array, integers. All right. So then when I say, okay, in that array, give me the first slot and set its value to 3. Okay. So the way that we can go through a two-dimensional array, assigning random variables, random values rather, to each item in that two-dimensional array. We can loop through the outer array, which just basically is going to go 0 up to 9, right? To get what row we're looking at. Then for each row, we then say, okay, now go through each item in that subarray, and for each one, access its position and assign it a new value. Now notice here, we use matrix I.length. And there's a number of reasons for why we do this. One, we can't just use matrix.length here, because even though in this example it's a 10 by 10 array, there's nothing that requires the number of columns and rows to be the same. Okay, we could have it be a 10 by 20 array. Okay, so it doesn't have to be the same number of rows and columns. It just so happens in this example it is. So then you might say, okay, well, why not just say, okay, matrix.0? Why not just say, take the first one, whatever the first one is. There's also a reason for that. As we talked about a moment ago, we'll show an example of what's called a ragged array, where each subarray isn't necessarily always the same length. And I'll even show you how to make a ragged array in a way that's even more dynamic than what the example in the text shows. All right. All right. So if we look at it this way, right? So here's an example where we have a 5 by 5 array. We just initialize a new array that's 5 by 5. Then we say, okay, I want to set the third array second position to be equal to 7. Okay. Now what happens? So we first look for which row is that. It's the row with index 2. So 0 is this row, 1 is this row, 2 is this row. Okay, so this is the array we get. This 5 value array right here. Okay. And then we say go to index 1. So here we are, this one, right? And we say set it equal to 7. So that's how this happens here. Okay. Now notice matrix.length is 5. Why? Because the number of arrays, the number of items in the main array is 5. The number of arrays is 5. Matrix 0.length, okay, matrix of 0.length, it just says, okay, what is the first item in here? What is its length? Okay. Now, if I were to say, okay, well, what is matrix? Zero dot length. What would I get here? What would I get here? What do you think? Some comments? Okay. And okay, so you get a lot of you thinking 1, okay. Or 0. Or Emory says an error. Okay. All right. Good. You guys are thinking through. Okay. So I'm assuming those of you thinking 1 are saying 1 because it's only one item. Right. 0 because it's not an array at all. Array. Right. So I'll show you an example in just a moment to show, but those of you who are thinking error, yes, the reason why is because once we get to this, so this matrix is an array, is an array. Now, what we know, all of the compiler, at the runtime, the only thing that we know is that this is an array of values. It's an array of things, right? Specifically, it's at some level down below. The compiler also knows that there's integers involved. Okay, in this particular example. Okay. Now, when we get to this, what the compiler, at the runtime rather, the execution of this program, what it sees is this is an array, right? When we get to this, we get a specific value that's stored in memory. So yes, those of you who are saying it's a variable, yes, it is treated as if it's just an integer variable. So this would be the same as if I were to say int var equals 0, and then I were to say, okay, now what's var.length? And what would happen is the compiler, actually this would be a compiler error, because the compiler would say there's no such thing as a length attribute on a primitive data type, on a primitive integer variable. Okay, so this would give me an error. And I'll show you that in just a moment. Now here it's slightly different because it's a different number of rows and columns. So here we can declare an array just like the same way that we've done before, where we can actually just give it a set of initial values to start with rather than trying to loop through and set our own values. Okay, and what we've done here is we create a what's called a 3x4 array. No, rows first, so 4x3 array. Now, so when we say what is the length of the overall array, what we're really asking is what are the number of columns? Sorry, opposite. What are the number of rows? Okay, so how many arrays are inside of this? Well, 4. If I were to say, okay, what is the length of the first array in our multidimensional array? And that's 3. There's 3 values there. Okay. We got a question or comment? Plus, okay. All right, so this is how we can get a different value for the array.length versus the array 0.length. Is one is saying how many arrays are in there, the other is saying what is the number of columns that are in there. How many items are in that first array? Okay. All right, so again, just like before, we can declare an array and seed with values very quickly rather than trying to assign them each individually. This would be the same as if we had done this.
How many times is that you teaching Java or Python?
Okay. And again, just like before, where an array, a single one-dimensional array, was a set of what we call contiguous memory locations, where before each of these spots contained a value, contained an integer value. Now each of these spots is going to contain a pointer to a second array. Okay. So here, instead of a 4x3, now we have a 3x4. Okay. We have 3 rows of 4 columns. So this points to an array of 4 items. This points to an array of 4 items. This points to an array of 4 items. Okay. And as we'll see again towards the end, as we get into more than just 2 dimensions, is each of these items itself can also point to another array. So we can take this and say, point that to another array, this, point that to another array, this, point that to another array, and we can end up with 3 dimensions or more. Yes, Recep Summit, yes, we'll get to that in just a moment. We'll call that, I've mentioned that a few minutes ago. Maybe you joined a little bit late, but we talked about, I mentioned about ragged arrays, and we'll talk about that in just a moment. It'll probably come up in the second hour. I will not get there in the first hour before the break. Okay. Actually, that's where we'll end. I thought it was later in this set of slides. Okay, so just like before, if we were to say, okay, array.length is how many arrays are in my matrix, right? So 1, 2, 3, 4. So array.length would be 4. Each of these, array of 0.length would be 3. Array of 1.length would be 3. Array of 2.length would be 3. Array of 3.length would be 3. Array 4.length will give me an array index out of bounds because there is no item in here with index 4. Okay, this is 0, this is 1, this is 2, this is 3. 4 does not exist, just like before. Okay, all right. So where we'll end for this first hour here is I do want to go ahead and mention the ragged arrays to answer your question. Rita Jepson. All right, is what we can do is we can initialize a two-dimensional array with a bunch of arrays of different sizes. So here now the first item points to an array of 5 items. The second item points to an array of 4 items. The third item points to an array of this. The fourth points, fifth points to an array of only 1 item. Okay. And again, the way this would look graphically, the way this would look visually, is remember, each of these items in the triangle array, it's a set of memory locations that each points to something. Points to, in this case, an integer array. Okay. Now, this value here is not, the value here is not 5. Okay, this is a key thing I want to make sure everyone knows. What this last item points to is not the value 5. This points to an array of 1 item whose value is 5. Okay, now that's a slight difference. Okay. And the reason why is because I can't change this last item. Like I couldn't do, let me go back to here and edit here. I couldn't do this. That will not work. This will give me a compiler error. And the reason why is because this is an array. This is an array. This is an array. This is an array. This has to be an array. If it's not an array, I will get a compiler error. All of the data types have to be the same. Okay. For those of you who have previous programming experience, if you've ever programmed in C or in Java before, this is normal for you. You're saying, well, yeah, of course, all the data types have to be the same in an array. Okay, C and Java work that way. If you've programmed in Python before, this may be a little bit confusing and a little bit like, why is it doing this? Because Python does allow for mixtures of data types. Okay, Java does not. Sorry, it's just the way it is. Okay, so again, the last item here is not the value 5. It is an array that consists of 1 item whose value is 5. Okay. If I can share, I do want to go ahead and end this first hour. And if I can share the Microsoft whiteboard, I will do it that way. It allows me. There's a lot of stuff. Okay, so you guys remember this. This is where we left off last week, right? So this is just left off here before. Okay, so you remember this is where I left off, was what we were talking about, was where you have an array that points to a set of memory locations, and if each of those points to an array on its own, this is what a two-dimensional array is. Okay, and so what we are seeing here, if I can move this over. Can I move this over? It doesn't look like I can. Okay, let me just erase this stuff. So this points to an array of 5 items. This points to another array, of, in our example here, four items, right? Okay, and then basically what we get down to is that we have this subarray down here that does not point to the value 5, but points to an array of 1 item that itself is the value of 5. Okay, it can get a little bit confusing, but it is for consistency. And the reason why is because if we were to access the array, if we were to say, I want the first item in the first array, we would access it using that bracket notation like this, right? But if I were to say I want that last array, I think it was no, it wasn't 5, it was 4. Okay? I can't just access that and get the value 5. I have to say I want the first item in there. Okay, it's for maintaining that consistency of how we note it. So every time we want to access a value, we're going to have to use two indices, two index values. One to give me which row, one to give me which column. So in the same way, I still have to tell my program what row and what column I want to get. Okay, so we will end our first hour there. I know we started late, but we will still end for the first break at a normal time at 10:20. So I'll go ahead and stop the recording, and we can rejoin again in 10 minutes. So 10:30, we will start up again. Okay. All right. See you in 10 minutes.